In this video, I'll be teaching the first principles for differentiation, which are really important to understand if you want to follow along in your calculus class. Calculus is a whole new section of math which relates to many previous topics, so it's important to touch up on those if you need to. For this video, it would be benefit you greatly if you're comfortable with finding the slope of equations, function notation, and just a little bit of binomial theorem. Just looking at the formula for first principles is kind of confusing, since it looks like there's like a bunch of stuff going on, like, what? By the end of this video, you'll hopefully understand where all this comes from, and if not, at the very least, you'll understand how to use it to solve questions. Well, until we get to the power rule. The YouTube video will have chapters, which you can see in the seek bar, so if you already know something or just want to revisit something, you can click back and forth and check it out. So, what does it mean to take the derivative or differentiate a function? To understand this, we can first look at what it means to find the average rate of change in a function. The average rate of change is how much the y value changes between two x values. Physics students will recognize this as the formula for average acceleration here, or with delta, meaning change in. So when finding the average slope, 2 points are selected on the x-axis, like so. This will be x1 and this will be x2. So the change in vertical height between these points divided by the horizontal slope, so the vertical height divided by the horizontal distance here, will give you the slope. Rise over run, remember? Visually, the slope would look like this. So you'd have a point here and a point here. These two would connect. And here is your travel distance. This is the change in x, and this is the change in y. And it's always change in y divided by change in x for the slope. So it's great that we know how to do this, but what about the slope at a single point? What if I wanted to know which exact point on this x-axis has the highest or lowest rate of increase of y? That's when we get to finding the instantaneous rate of change, also known as taking the derivative, or differentiating the function. The idea behind this is that you have a singular point which you want to find the slope of, and you start off by taking that point as it is there and having it horizontally as well for the y, and moving over an infinitesimally small amount, so the smallest amount possible, also known as approaching zero through limits. And this will be your x1 and x2 instead. Obviously, when you are drawing this out, you can't show this. So what you're really doing, if we zoomed in infinitely, you'd have your slope like this. And what you're doing is moving over by 0.001 and going up by 0.000 infinitely 1. And you're finding in the same way, rise over run, you're finding the slope through the change in y over the change in x. So in calculus, when we move a infinitesimal amount, this is called dy over dx. The reasoning for this process being called differentiation, in fact, is because you're moving such a small amount, where the difference is approaching 0, which we saw in the beginning of the video in the first principle. So as for where they get this lengthy looking beast of a formula, f of x plus h minus f of x all divided by h, where all the h's are approaching 0. The way they obtain this is they look at this infinitesimal difference. So to find the height, you would have y2 minus y1. So you have to remember from a function notation that f of x is just the same thing as y. So what we have here is x2. This is x2 because it is x plus that infinitesimal amount. And then we have the x1, which is the original point you picked. So this allows you to work with one point and find the slope. So let's say we have the function y equals x squared. This is a classic. Everyone will start with this example in first principles. So what you're going to do is plug in x squared. Well, this is your new input, and you're going to plug in this input for every instance of x squared. This is a common mistake I see people doing, where they don't realize that this is their function. This is f of x, which is the same thing as y. So you would have x plus h squared, not x squared plus h in brackets like this. It would not look like that. So you'd have x plus h squared minus the original function, which was just x squared, all divided by h. So you might be thinking, well, h approaches 0, and you're dividing by h. You can't divide by 0. So the thing about the first principle is it shows us clearly how calculus works. You get to cancel out where there would be a hole, and you can find certain truths about a function that you might not otherwise find without using these rules. So this is where I said binomial theorem would come in handy. So you're going to want to expand x plus h squared. You would get x squared plus 2xh plus h squared. Then we have minus x squared, all divided by h. So here we have plus x squared minus x squared. So h approaches 0. The x squares will cancel out. You get 2xh plus h squared, all divided by h. So you'll notice a common term in both the numerator and denominator. The h is common, so we can factor out the h from the top. 2x plus h, all divided by h. And these two will cancel. So you're left with limit as h approaches 0, 2x plus h. So one of the rules of limits is that this is within like the realm of reality. We can just add 0 to 2x. So we can ignore this limit now. We can say 2x plus 0 is our answer, which is obviously 2x. But what did we find here? 2x is the derivative of this function x squared. We write this out as dy divided by dx, which is not a fraction, by the way. You can't cancel out the d's, equals 2x. You might see some textbooks or in your exams, they might write it as y prime equals 2x. Prime just meaning differentiated, and y is the function. Or f prime of x equals 2x. Now these all mean the same thing. Some of them are more useful than others, and they all have their place within calculus. And I think it's worth remembering all of them. Just be careful not to cancel out the d's like I did when I first started. It's pretty silly. So with this, you should understand how to use first principles to find the derivative. So this is the derivative function of x squared. What this function does, if we think about the graph of x squared, what this function does is allow us to find the slope at any given point. So let's say we want to find the slope at x equals 0. So x equals 0 here. We can see that the slope is 0 because it is not increasing nor decreasing. If we plug in dy dx at x equals 0, you'll see that 2 times 0 equals 0. This checks out. But what about maybe 10, like around here? we'll find out that the slope at 10 is equivalent to 20, which means it is rising 20 y units for every x unit in this one point. It's a very, very steep increase compared to the previous ones here. So this kind of lays the groundwork for something you'll learn about later, known as the power rule. And yeah, I hope you understand how derivatives work, just the first principles. And ask me in the comments if you need anything.